Alright, this is the Unit 12, Day 9 review sheet continued. Can't fit it all in one video because these problems are big. Alright, a person's lung capacity can be modeled by this function. C of T represents the volume in milliliters present in the lungs after T seconds. State the maximum value of this function over one full cycle and explain what it represents. Alright, so it's a sine. Remember, sine curves look like this. The midline would be right here, the baseline, which is your vertical shift, so that's to 2,450. Amplitude tells you how high above and below the midline you go. So if you add the 250 for the amplitude, that says that our maximum volume up here at the top would be 2,700. So 2,700 milliliters is the maximum capacity of the person's lungs. So when they explain in context to the question, you just go back and see what we're talking about. So that's the max capacity of a person's lungs. On July 21st, 2016, the water level in Puget Sound reached a high of 2.1 and a low of -2. Across the country in Long Island, Shinnecock's Bay water level reached a high of 2.5 and a low of -0.1. Water levels of both locations are affected by the tides and can be modeled by sinusoidal functions. Determine the difference in amplitudes in feet for these two locations. Alright, so we don't have to write the entire equation, we just need to find the amplitude. Well, to find the amplitude, we need to find the midline. Midline is halfway between lowest and highest. So I'll do PS for Puget Sound. We have 10.1 plus -2 divided by 2. So that's going to be 8.1 divided by 2. Midline is 4.05. So the amplitude is the distance from the midline to either the highest or lowest. So if I take the maximum and subtract the midline, then that's going to give me 6.05 for the amplitude for Puget Sound. Shinnecock Bay we'll call SB. Finding the midline, so we're going to find the average between the highest and lowest. So that's 2.4 divided by 2 is going to be 1.2. So we take the highest value and subtract the midline, and that tells us that our amplitude is 1.3. Alright, so I guess there's no real competition here. The difference in to find the difference in the amplitude. So now we got to subtract the two amplitudes. I thought we were just finding the highest one. Alright, so when we subtract those amplitudes, the difference in amplitudes is 4.75. Excuse me. Write an equation for a sine function of amplitude of t at 3 to pi halves and sketch it. Alright, so amplitude is 2. Period, it didn't say anything about a vertical shift, so we don't have a midline. Midline 0. If the period is pi over 2, period is 2 pi divided by frequency. We need the frequency for the equation. So plug in the period, cross multiply. So the frequency, when the pi's cancel out, is 4. So to write the equation, we have y equals amplitude, trig, frequency with an x, and then there's no vertical shift. Alright, so graphing this thing, again, the period is pi halves. We have to graph it all the way to 2 pi. Let's draw the axes in there. And I'm going to say that's 1, that's 2. I'm just spacing it out because the grid's so small. Alright, so the period is pi over 2, and I know that there are 4 critical points to get to a period. So I can actually go calculate them if I want to, or I can draw 4 of them. So here's 1, 2, 3, 4. I don't think I'm going to have enough room that way. I'm going to go 1 block at a time. So 1, 2, 3, 4, and I label it pi over 2. So if I go 1, 2, 3, 4 more, and I've gone another whole period, pi halves and pi halves make a whole pi. So I'm going to go 1, 2, 3, 4 more, and that's 1.5 pi's, or we would know it as 3 over 2 pi. 1, 2, 3, 4 more would be 4 halves pi, which is 2 pi. And they asked us to graph from 0 to 2 pi. Alright, so it's a sine graph. That means it starts at 0, up to the amplitude, midline, down, midline, and you do it over and over again until you get to the 2 pi they wanted. And there's our graph. So we do have 4 complete cycles of sine between 0 and 2 pi, which is exactly what the frequency means. Relative to the graph of y equals 3 sine x, what is the shift of the graph? This is nothing more than a transformation question. It really has nothing to do with the trig. So remember, when you're doing transformations, if it's a horizontal and it's in parentheses with the x, it goes the opposite direction that the sign appears. So instead of positive going to the right, I know it's opposite, so it's going to go to the left pi thirds. Which graph represents cosine function with no horizontal shift, amplitude of 2, and a period of 2/3 pi? Alright, well, first of all, it says it has to be cosine. If it's not got a horizontal shift, cosine starts somewhere other than 0, because there's no vertical shift either. So let's see, that means graph 2 is out because it starts at 0, that's a sine. Graph 4 is out because it starts at 0, and that's a sine. Amplitude 2. Now remember, amplitudes are always given as positive numbers, so the fact that number 3 is upside down has nothing to do with this, because both choices 1 and 2 have an amplitude of 2. So now we got to work on the period. The period is how long it takes to finish one full cycle. Well, a full cycle of sine is a whole V. So if you take a look at choice number 1, the end of the V is right here, and that happens even before you get to 1/3 pi, way before 2/3. So there's no way it can be graph number 1. If we look at graph number 2, a whole V ends right here, which is almost to a whole pi. Well, 2/3 pi is pretty close to a whole pi, so we've eliminated all the other answers anyway. It's got to be graph number 3. Ferris wheel takes 7 minutes to make one full rotation. The height is given by this function, where t is the time in minutes. Using h of t for one full rotation, what's the car's minimum height? Okay, so again, we know for a sine curve, here's our midline. Okay, that's where the sine curve starts and ends. And the midline plus the amplitude gives us the maximum height. Midline minus the amplitude will give us the minimum height. So the midline from the equation is the 80, that's the vertical shift. Amplitude is what happens in front of the sine, the trig value, so when we subtract the 70, that means the minimum height is 10 feet. The voltage used by most households can be modeled by a sine function. The max voltage is 120. There are 60 cycles every second. Which equation best represents the value of the voltage? Alright, well, you notice all of them have 120 for an amplitude, so amplitude apparently has nothing to do with this. None of them have a vertical shift, so we're starting at 0, so I'm guessing everything has to do with this 60 cycles every second. Frequency tells you how often things happen. Period tells you how long one cycle happens. So if I've got 60 cycles every second, then if I take that 1 second and divide it by 60, that tells me it takes 1/60th of a second for one cycle. If 1/60th is the time for one cycle, then 1/60th equals my period. We know that period is equal to 2 pi divided by the frequency. So I need to pick the answer choice that when I divide, I am going to get 1/60. First thing that I notice is that I don't have a pi in my period at all. So if I don't have a pi in my period, I have to have a pi with my frequency to get those pi's to cancel out. So I am going to eliminate choice 1 and 2 right now because they don't have a pi. So then I'm going to look at choice 3 and 4. If I take 2 pi and divide it by this frequency of 60 pi, the pi's cancel, but I get 1/30, which is not correct. So then I'm going to take the next example, 2 pi divided by 120 pi, the pi's cancel, and there's my 1/60th of a second that I need for my one cycle. So the answer is number 4. On the axis below, graph one cycle of a cosine function. Alright, so it didn't say we had to write the equation. So we have a midline of y equals -1. I'm going to graph that. Amplitude is 3, so I'm going to go 3 above it and 3 below it. Period is pi halves, so that means I have my 4 critical points, and the last one's going to be labeled pi halves because that's the period. And I pass through the point 0,2. I didn't actually need that information at all because when you have an amplitude of 3 and a cosine graph starts somewhere other than 0, I guess they did have to give it to me because that way I know that my cosine curve is right side up instead of upside down. Because the amplitude of 3, it could be either a right side up or an upside down cosine. So giving me this point does tell me it's right side up. Okay, so we start in the air for cosine, go to the midline, min, midline, max. Make it a curvy sort of V, and there's our graph. Which equation is represented by the graph below? Well, let's see. Midline is halfway between highest and lowest. Halfway between highest and lowest looks like 0. So my amplitude is 0.5, so I can eliminate choice 2 and 4 already. Now I just have to figure out what my period is so I can get the frequency. So I'm starting at the maximum here, and I end up at a maximum over here. That's 1 full cycle of cosine, so my period is equal to pi. So if I can fit 1 full cosine curve in by the time I hit pi, that means I'm going to hit 2 full cosine curves by 2 pi, meaning my frequency should be 2. If you don't like that, period equals 2 pi divided by frequency. My period is pi. Cross multiply and solve. So pi times f equals 2 pi. Divide by pi. There you go. Frequency is 2. Gotta be choice 1. Based on climate data collected in Bar Harbor, Maine, the average monthly temperature is modeled by that equation. The same government agency collected the monthly temperature for Phoenix, and it's modeled by the second equation. Which statement cannot be concluded based on the average monthly temp models? The average monthly temperature variation is more in Bar Harbor than Phoenix. So the variation would be the difference between the highest and the lowest. So let's see, for Bar Harbor, the maximum is going to be the midline plus the amplitude. And for Phoenix, same thing. It's going to be the midline plus the amplitude. Well, actually, probably don't even need that much. the variation is how much it goes up or down. All we need to do is look at the amplitude. I'm doing too much work here. So the amplitude for Bar Harbor is higher than the amplitude for Phoenix, which means it goes up more and it goes down more than Phoenix. So number 1 is true, and we're looking for the one that's false. Alright, the midline temperature for Bar Harbor is lower than the midline for Phoenix. Well, midline for Bar Harbor is 55.3 and Phoenix is 86.729, so that statement is true, not the one we're looking for. The maximum temp for Bar Harbor is 79. Okay, we'll go back to where I was trying to find the maximum. Midline plus amplitude. So we take 55.3 and add it to 23.914. We get 79.2. So number 3 is true. Minimum temperature for Phoenix. Alright, well, we've eliminated the other one, so this has got to be it, but let's work it out anyway. So minimum is your midline minus your amplitude. Helps if I type it in right. 86.729 minus 20.238, and we get 66.491 degrees, so number 4 is correct. Alright, this function represents a damped sound wave function. What's the average rate of change for this function from -7 to 7? Alright, so this really has nothing to do with the trig itself. This is just rate of change, so rise over run. We have to plug in the -7 and 7 and find out what the values are. I wouldn't recommend trying to make a table for this one because you have to be the master of parentheses to get it to work right. So let's do it old-fashioned way. Plug in the -7. 2 to the -0.25 excuse me, times 7 times sine of pi halves times -7. Alright, I am going to get, well, no, I'm not either. Make sure if your exponent has more than one item in it that you put it in parentheses. So this is going to go in parentheses. Just like this is going to go in parentheses. So carefully, 2 caret, this is more of a typing problem than anything, -0.25 times -7 in parentheses times sine, now make sure your calculator's in radians, pi halves times -7 and parentheses, and I get 3.363585661. So when x is -7, that's my value. I'm going to go back and plug in a +7, but I'm going to hit second enter so I don't have to retype everything, and just go delete the negatives off the 7s. Shortcut. Hit enter, and I get -0.29730177788. I do not ever like to round until I am done. If you don't want to write that much, whatever they tell you to round to, go at least 2 more decimal places until the very end. Alright, rise over run. So 3.36358 minus a -0.297301 all over -7 minus 7. Alright, so in the numerator, 3.36358 minus a negative is plus 0.297301, and I get 3.660881 all over -14, and I'm coming out with -0.261, so that would be choice number 3. The graph below represents the height above the ground in inches of a point on a triathlete's bike wheel during a training ride in terms of time in seconds. Identify the period of the graph. Describe what it means. Alright, so this looks like a cosine curve because it does not start at the midline. Your first cosine curve ends at 2/3 seconds. And a period always means the amount of time for one cycle. So what it means is it takes 2/3 of a second for the wheel to make a full turn. A sine function increasing through the origin can be used to model light waves. A violet light has a wavelength of 400 nanometers, over which interval is the height of the wave decreasing only. Alright, well we know sine starts at 0, and it has a wavelength of 400, so it's going to go up 400, down, and back. So if it has a wavelength of 400, then this x value at the end is 400. A wavelength is a full cycle. Alright, so when is it decreasing only? Well, we know we have 4 critical points in between 0 and our period. So if the period's 400, then each one of these has to be 100. Well, that'll be 200, 300. Where is the function decreasing? It starts decreasing here at the top of the hill and to the bottom of the trough. So between x values of 100 and 300, this graph is decreasing. The volume of air in a person's lung as they breathe in and breathe out can be modeled by a sine graph. The scientist is studying the difference in this volume for people at rest compared to people told to take a deep breath. When examining the graph, the science should focus on either amplitude, period, or midline. Okay, so midline would be the average volume. They didn't say anything about average. They're just talking about plain old the volume. The period would have to be the time that they're taking the breath. So that shouldn't have anything to do with it. Amplitude has everything to do with how much air you can put in your lungs and how much air you can take out. So in this case, it is going to be amplitude. Amplitude tells the max and min amount of air in the lungs. So if you're taking in a deep breath, we'd want to know how much air is in there. That's amplitude. Alright, as x increases from 0 to pi halves, what's the equation of y equal to tan x doing? They don't do a lot with tan graphs. It's been a while since you've seen them, but a period for a tan graph is pi, and it's only has 2 critical points. So here's pi halves, and here's pi. Remember, tans have the asymptotes. So pi halves, remember, is kind of like 90 degrees. Pi is 180 degrees. So what's the tangent at 0 degrees? Well, this point is 1, 0. Tangent is sine over cosine, so 0 over 1 means the tan right here is 0. 90 degrees is the point 0, 1. Tan is sine over cosine, which is 1 over 0, making it undefined. So we get an asymptote here at 90. And if you remember, a regular tan graph is kind of like a disco, up and right for the positive, and then if I needed the graph, it would have been down and left from the pi. But it's asking what happens from 0 to 2 pi. The tan's going to go up, but because of that asymptote, it goes up forever, so it increases without limit. Tans go as high as they want. That amplitude just changes how fast it's going to go up forever. Alright, which sinusoid has the greatest amplitude? Well, number 2 has an amplitude of 3. Number 4 has an amplitude of 5, so choice 2 is out. Let's see, the highest the graph in number 3 gets is 3. The lowest is -5. So if you add those together, you'll get the midline, which is -1. So the amplitude is how high above the midline it goes, and that's only 4 units. So that's out. graph number 1, the highest is at 7, the lowest is at 2. So if you add those together and cut them in half, the midline is at 4.5. And the distance between 4.5 and 7 is not bigger than 5. So number 4 has the greatest amplitude. Sketch at least one cycle of a sine curve with an amplitude of 2, midline at y equals -3/2, and a period of 2 pi. Well, the period of 2 pi is nice. So 1, 2, 3, 4 critical points, label it 2 pi. Midline is -1.5, so we'll draw that right here. Amplitude of 2. Alright, so if we're at -1.5, -1/2 would be 1, then 0, +1/2 would be 2 places up. So there's 1, there's 2. Going down, here's -2.5, so that would make 1. -3, -3.5 would be going down 2. So my max value is 0.5. My min value is -3.5, and we are doing a sine curve. Sine curves start on the midline, go to the max, midline, min, midline. There's our sine curve. Explain why any differences between the sketch of this function and the one that we did. Well, the one that we did had an amplitude of 2. It had a frequency of 1 because I only did one sine curve. It did have a vertical shift of -3/2. So if we wrote the equation of what we just graphed, that's what we get. So the only difference in this equation is that -π3, which is a horizontal shift. Opposite of that means it's shifted right π3. That's the only difference of that graph. Alright, we are at the end of the review sheet. That was every trig question that's ever been put on a Common Core Regents exam. That's why this review sheet was lengthy. Just wanted to let you know exactly what has shown up before. These are the kind of questions that they have put on the Regents exam. Hope you did well, and if you have any questions, again, reach out to Mr. Kaya or myself.